Okay, today we're looking at Unit 5, Lesson 1, Solving Systems by Elimination. And so we looked at solving systems last week using matrices, and so they will kind of look the same. So let's say I have 2x minus 3y equals 5, and 4x plus 3y equals 1. Now, we're solving by elimination, so this means I'm going to literally add my functions together, or my equations together, so that one of the variables, either the x or the y, will cancel out. So this system that I have is already set up so that my y's will cancel out. Notice they have the same number and opposite signs. So if I add these two together, negative 3y plus 3y is 0, so the y's just cancel out. So let's go ahead and add these together. 2x plus 4x is 6x. Negative 3y plus 3y is 0, so those cancel out. And this is equal to 5 plus 1 gives me 6. So I added the x's, I added the y's, and then I added the plain numbers together. So now this is a basic equation that we can solve. Divide both sides by 6. And I get x is equal to 1. Now that I know what x is, I can take either one of my equations, plug it back in, and solve for y. So I'm just going to take the top equation and plug x in. 1 equals x, plug 1 in for x. So I'm going to have 2 times 1 minus 3y equals 5. So I have 2 minus 3y equals 5. Subtract 2 from both sides. 2's cancel out. I get negative 3y equals 3. Divide both sides by negative 3. And I get y equals negative 1. So my solution is x equals 1, y equals negative 1. And the solution is where these two lines cross each other on a graph. So I could write the solutions as 1, comma, negative 1. So there is my answer either way. Depends on what the answer's asking for. Okay? Now, very important, one, these are lined up in a certain way. As long as your x's are over your x, y's over the y's, equal sign over the equal sign, and the number over the number, then you're fine. They don't technically have to be in this order. So let's look at another example. This one was set up for elimination. So let's look at one that's not set up for elimination and how we go about forcing it to be that way. So let's say I have 5y plus 3x equals 9 and 2y plus 4x equals negative 2. Now, again, I have y's over y's, x's over x's, equal sign over equal sign, number over number. So it's lined up fine, but I don't have anything that's going to cancel out. So I need to force this to cancel out. It does not matter if I choose my y's to cancel out or my x's to cancel out. I'm going to go ahead and go with the x's because last time we canceled out the y's. So it doesn't matter which one we start with. Now, in order to cancel out my x's, the number in front has to be the same. So this is kind of like finding the common denominator. So between 3 and 4, if these were fractions, my common denominator would be 12. So this is the number that I'm trying to get, is 12. I need one to be positive, one to be negative. Does not matter which one I choose to be what. In order, I'm just going to say the top needs to be negative. You could do the bottom negative, it doesn't matter. But in order for the number in front of x to be negative 12, I need to multiply my top equation, the whole thing, times negative 4. Now, if I'm going to make the top negative 12, I would need the bottom to be positive 12. So I need to multiply the bottom times positive 3 to get a positive 12. So my new, that's an arrow, my new equations, I'm going to multiply everything in the top equation times negative 4. So I'm going to get negative 20y minus 12x equals negative 36. And on the bottom, multiplying times 3, I'm going to get 6y plus 12x equals negative 6. Okay, so now the x's, if I add these two equations together, will cancel out. So I'm going to add these together. Negative 20y plus 6y gives me negative 14y. Negative 12x plus 12x is 0, it cancels out, equals negative 36 minus 6, or plus negative 6, is negative 42. So now again, I have a simple equation that we can solve. I'm going to divide both sides by negative 14, and I get y equals negative divided by negative as a positive. 42 divided by 14 gives me 3. So now I know what y is equal to. Y is equal to 3, so I'm going to take it and plug it back into any one of my equations. It doesn't matter which one. I technically have 4 to work with now. But I'm going to take this bottom equation. It's got smaller numbers, so I feel like it would be easier, but it doesn't matter which one you choose. So I'm going to take 3 and plug it in for y into one of my equations. So I'll have 2 times 3, because that's where y is, plus 4x equals negative 2. So I get 6 plus 4x equals negative 2. Is that kind of blurry? See if I can fix that real quick. Oh, that's probably better. Okay. So now I need to solve. Subtract 6 from both sides. I get 4x equals negative 8. Divide both sides by 4. X equals a negative divided by a positive is a negative, and 8 divided by 4 is 2. So I have x equals negative 2 and y equals 3. Again, depending on the format of how we should write our solution, I can either leave it this way, or I can write it as a coordinate, negative 2, comma 3. Just depends. Okay, and you'll see if you have multiple choice or you're filling in the blank or something, you'll see how the answer should be written. But there you go. All right, so let's look at one more example. Both the examples we've looked at already had the variables lined up. So let's look at one where the variables are not lined up. I have x minus 4y equals 6, and y equals x minus 3. Now, I don't have y over y, equal sign over equal sign, x over x. So I need to manipulate this equation, either one of them, both of them, so that x's over x's, y's over y's, equal sign over equal sign, number over number. It doesn't have to be in that order, but everything needs to be lined up. So this one's already solved for y, so I'm just going to move, let's see, I guess I'll move this x to the left side. If you want to manipulate it in a different way, that's totally fine. However you see it, whichever way will be easier for you. But I'm going to move this x to the other side. And so this equation will stay the same, x minus 4y equals 6. And I'm going to move this one to the left by subtracting. So I'm going to subtract x from both sides. And so I'll end up with negative x plus y equals, this x went away, so I have negative 3. And now it's lined up, x's over x's, y's over y's, equal sign over equal sign, number over number, so that I can solve it. This one ended up already being set up to solve, so I'm just going to go ahead and add these together. Right, I have positive 1 and I have negative 1 in front of my x's, so I can combine them. X minus x, or x plus negative x, however you want to look at it, is 0, so that cancels out. Negative 4y plus 1y, right, that's an understood 1, is negative 3y. And 6 plus negative 3, or 6 minus 3, is positive 3. So I'll divide both sides by negative 3, and I get y equals negative 1. Now I know what y is equal to, and so I can plug it into any one of my equations, it doesn't matter which one I choose, to solve for x. This one's already solved for y, so I'm just going to go ahead and use that one, but again, it does not matter which one you choose. And so I have negative 1 equals x minus 3. Add 3 to both sides to get x all by itself. And I get x equals negative 1 plus 3 is 2. So there we go, x is 2 and y is negative 3. Again, depending on how my solution needs to be written, I can either leave it like this, x equals 2 and y equals negative 1, or I can write it as a coordinate. So, any of those. Okay? Y'all have a good day. If you have questions, of course, come ask.